Hey there, we're talking about 85 through 89. Number 85. This is a quadratic that has been factored, and now it's been set equal to 0. And that means that I can use the zero product property. Basically, that says that if these two together multiplied equals 0, then either this one must be 0 or that one must be 0. If either one of those things is true, then when it gets multiplied, it'll make 0. So if this part is 0, the only way that could happen is if x was 4. And if this part to be 0, the way that could happen is x was negative 5. So once you've got a quadratic solved down, or factored down to look like this, it's really easy to solve them. You just have to set this part equal to 0, like x minus 4 equals 0, and then add 4 to both sides, x equals 4. I was kind of doing that in my head before. Or set this side equal to 0, x plus 5 equals 0, and then minus 5 from both sides, x equals negative 5. Okay, these are the two things that would make it 0. Now to test it, I could just actually stick in a 4 right here, and I'll have 4 minus 4 is 0, and 0 times 9 makes 0. So it worked. And test the other answer of negative 5. I could stick in a negative 5 here, and that's going to make 0. 0 times negative 5 minus 4 is negative 9. 0 times negative 9 would make 0. So it worked. All right, that is how to do that kind. Next one, solving with substitution. Basically, when you have a system of two equations like this, and you want to solve it with substitution, you're saying that you want to substitute in this equation into the other one, or vice versa. Now, it really helps if your equation is solved for something. All right, right now I've got both of them solved for y. Y is equal to that, and y is equal to that. So I can do substitution by just basically taking one of those two and plugging it into the other. If y is really equal to 2x minus 7, then instead of the y right here, I'm going to put 2x minus 7. I'm going to substitute it in there. So I'll have 2x minus 7 is equal to x minus 5. All right, that's just replacing the y with a 2x minus 7. All right, now I can just solve it like a normal equation. I got variables on both sides, get rid of the smaller one, taking away x from both sides, and I'll have x minus 7 is equal to negative 5. Then I'm going to add 7 to both sides. X equals to, if I add 7 here and add 7 here, I have 2. Okay, and now that I know x is 2, it's really easy to figure out where y is. So I come back up to my original equations, and I can plug that into either one. If I know x is 2, I could plug it into either one. This one looks a little easier though, so I'll plug it in there. So if I rewrite this equation right here with y equals, and instead of x I put 2, 2 minus 5, then y would be equal to negative 3. So that's the y and that's the x. Now these system of equations could have been solved in another way. You could have graphed the two equations and then saw where they crossed, and where they would cross would be at 2 comma negative 3. That's where they'd cross. Okay, that's a whole different way to solve. It's solved by graphing. All right, next one is solve with elimination. Elimination is just a different way to get an answer to these problems, and it basically means you line them up, you put them in standard form with x first and then y and then a constant. And here's x and y and then a constant. I got them lined up, and I want to make it so that when I combine these two straight up and down, like kind of like adding them together, that one of their variables will cancel out and be gone. Okay? Well, if I did negative 2x and positive x, that's going to make me down to negative x, but it doesn't cancel all the way. And if I add these two, that also doesn't cancel. That makes 4y when I add them. So I need to do something to my equation to make it work nicely. So I'm going to multiply the bottom equation by 2. And if I do this multiply by 2 here, I have to multiply by 2 everywhere. Okay, and so now my new equation will be 2x plus 2y equals 4. And I'm going to get this out of here, and I'm going to I'll bring my original equation down and say negative 2x plus 3y equals 1. Now do you see why I multiplied this all by 2? Because now this and this will cancel out. And then when I add straight down, I'm going to get 3y plus 2y makes 5y equals 1 plus 4 makes 5. So y must equal 1. Okay? So that was solving with elimination. So I'm going to now take my y equals 1, stick it back up into either equation, and I'd say the easier of the two equations looks like the second one, definitely. So I'm going to stick in y equals 1 in here. So I'm going to bring this over here to do that. X plus y equals 2, but I know y is equal to 1, so I'm going to stick a 1 right there. Okay, and now I have x must equal, we'll take away 1 from both sides, and you'd have 1. So my answer is, what is the solution to this system of equations? X must equal 1 and y must equal 1. And that would be the point 1 comma 1. That's the only combination that will, in this case, work in this equation and in this equation. Another way to say it would be as if I graphed these two equations, it's the place where they would cross. It's the one solution they both share. All right? On to the next topic. Solve with a quadratic formula. It says 0 equals x squared plus 3x minus 2. Now, if I'm going to use the quadratic formula, I better know the quadratic formula. The quadratic formula is x equals negative b, almost want to sing it, plus or minus square root b squared minus 4ac all over 2a. Then I'm going to use the a is the number in front right here, and that's a 1, even though I don't see it. It's a 1. B is 3, and c is negative 2. So now I'm going to go stick those numbers into my equation. Negative b, or some people say that opposite b, is how I start. Well, opposite of my b, which is 3, would be negative 3 plus or minus the square root of b squared. That would be 3 squared, which would be 9, minus 4 times a times c. Now I always do it that way because I note that the most mistakes are always made in this part of the equation. So 4 times a times c. A was 1 and c was negative 2. Now I simplify this part on the inside of the square root, and it is 9 minus 4 times 1 times negative 2. Well, there's two negatives in that, which makes it positive 8. And so this is really negative, oh wait, and I forgot to do my denominator. It's all over 2a. 2 times a, which is 1. Now I have negative 3 plus or minus the square root of 9. This part right here is where people make all the mistakes. 9 minus negative 8, which means 9 plus 8, which would be 17. All over 2 times 1 is 2. A lot of times their answers for these quadratic formula questions, and by the way, this is x equals, are complicated, and this one is. So if I didn't have a calculator available, that would be a good enough answer because it's in simplest radical form. If I had a calculator, I could figure out the square root of 17 and use a decimal, and then I'd do the problem once with plus and then once with minus, and I'd have my two answers. Okay, so there's a quadratic formula. It finds you the roots, or the zeros, of the graph. Moving on. This is one of my favorite and most important kinds of problems. This is a complicated equation. They're not incredibly hard, but they have a lot of steps, and it's really important to show your work very carefully. And if you're in a rush to solve these, you're very likely to get them wrong. So take your time and do one step at a time and show your work. I'm going to show a lot of steps on this. First thing I'm going to do is multiply this out. This times this and this times that. So I'm going to have 3x over 3. Okay, I could make this 3 over 1 if that would make you feel better, and see how it's 3x over 3. And then I go 3 times negative 2 makes negative 6. And then I have the plus 1 I'm going to bring down. And then I'm going to start multiplying this one out. Or maybe I shouldn't. Maybe I shouldn't try to do too many steps at once. So I'm just going to write this part out again. Alright, so I did one thing, and now I'm going to simplify it again. So 3 over 3, I notice that that can simplify to 1x. And the negative 6 plus 1 is minus 5. Is equal to, and now I'm going to multiply this part out. And I'll get 5x minus 10, and then minus 4. Alright, now my left side is all simplified already. And on my right side, 5x minus 10 minus 4 means 5x minus 14. See, I'm just doing one thing at a time, and it's getting simpler and simpler each time. Now I'm going to take away an x from both sides, and I'll have negative 5 is equal to 4x minus 14. Now I'm going to add 14 to both sides, and let's see, 14 minus 5 would be 9 is equal to 4x. And now, let me make sure I did that right. Add 14 to 5. Yeah, that's right. 14 with negative 5. All right, so then I'm almost done here. I have 4x equals 9. I'm just kind of rewriting it here so that I can have it the way I like it with the x on the left side. And then my answer, divided by 4 on both sides, is 9/4. I want you to know that a lot of times in real life you don't get a nice decimal, or excuse me, a nice clean integer answer. There's how I would show all my work on that problem. Have a great day.